All right, so this is going to be number 16. So let's look at 16, and this is on page 925. All right, so 16, you have this. All right, so make sure you understand that you are multiplying polynomials here. So what's that first polynomial that you see? 5y. Remember, a polynomial.
Number in the parentheses.
Say it again.
What's the last number in the parentheses?
Minus 10. So 5y, a polynomial is one or more terms, right? So this 5y is one term, a monomial. Remember we talked about monomial, binomial, trinomial? And then the other polynomial is what polynomial? What is it? Right, and that's a trinomial because it has how many terms? 3. And what am I doing to that monomial and that trinomial? Multiply. So hence the title of this section is Multiplying Polynomials. But when you have a monomial times a polynomial, a binomial or more terms, what process are you going to use to multiply those two things out? Distributive property. All right, so you're going to use distributive property. All right, now it helps for some of you. Now, for some of you, you don't have to do this step that I'm about to do, but for some of you, it may be helpful. So basically, you're saying, all right, I'm going to multiply 5y times the first term. What's the first term? Y squared. Plus, and then 5y times the second term, which is y. And then plus 5y times the third term. And what's the third term? Negative 10. All right, so that's what you're doing. So every term that's inside the parentheses, you're multiplying it by 5y, and that's what you see here. But many students, they'll just go from here, because it's not that difficult to go from here to the answer. So what's 5y times y squared? Remember, you multiply like bases, you add exponents. So I am using the product rule here. 5y to what power? The third. 5y to the third. Because 1 plus 2 is 3. All right, what about this one? 5y, a positive 5y times a positive y. 5y squared. All right, over here now, you have 5y times a negative 10, which is what? Negative 50y. Now, can I combine any of these terms that you see here? No. So there's your answer. All right, so that's number 16. Okay, number 24. Number 24, you have this. Okay, so 24, you have a negative 4b squared times 3b cubed minus 12b squared, and then minus 6. All right, so I need to multiply those two polynomials. One's a monomial, the other one's a trinomial. So what property am I going to use to do this? Distributive property. So every term that's inside the parentheses, I'm going to multiply by that monomial, negative 4b squared. And so at some point, you're just going to do this. You're going to say, all right, so what's a negative 4b times a positive 3b squared? So it's a negative 4 times 3. Negative 12. And what's b squared times b cubed? B to the 5th. So that's my first term. All right, so then you're going to cover the first one so you don't mess it up. And then you're going to say, now I'm going to multiply negative 4b squared times what? Negative 12b squared. So what's a negative 4 times a negative 12? Positive 48. And what's b squared times b squared? B to the 4th. All right, so make sure you got that. And then finally, just cover these two now, and you're left with this constant. So what's the negative 4 times the negative 6? So what's a negative 4b times a negative 6 then? B squared. All right. Are any of these like terms? No. So there's your answer. Okay, any questions? All right. 26. You have this monomial, 4xy squared times 7x cubed plus 3x squared y squared minus 9y cubed. That's what you have. All right, now, so this monomial, and see in the previous two, you only saw one variable. This one was the variable y. This one was the variable b. In this one, you have both variables x and y. So you just got to be a little bit careful when you have multiple variables. So if you need to put in that step, basically you're using a distributive property. So you're saying 4xy squared times the first term. What's the first term? 7x cubed plus, and then 4xy squared times the second term. What's the second term? Okay, plus, and then 4xy squared times the third term. What's the third term? Negative 9y cubed. All right, so that's what you're doing. So every term that's inside that parentheses is multiplied by this monomial. Okay, so now let's deal with this right here, this first product. What's 4 times 7? 28. All right, now, remember when you multiply like bases, you add exponents. So I am multiplying an x times an x cubed. So what's that? X to the fourth. And then the only y factor left is y to the second. And we tend to put in alphabetical order. So write x first, y second. If you put y squared first, it's no big deal, but we tend to put alphabetical order, and we tend to put the coefficient in front. Okay, the next one. What's a positive 4 times a positive 3?
12.
Positive 12. What's x times x squared?
X squared.
All right, now tell me what I get when I multiply the y's. Y to the fourth, because y squared times y squared is y to the fourth. All right, now the next one. What's a positive 4 times a negative 9? Negative 36. All right, what do you get when you multiply the x's together?
X.
It's just x. There's just one factor, right? What about the y's? Y to the, not the fourth, but to the fifth, right? All right, are any of these like terms?
No.
No. None of these are like terms, so there's your answer. All right, that was 26. 28. 28, you have this. All right, you have negative x times 6y cubed minus 5xy squared plus x squared y minus 5x cubed. So again, if you need to put in that middle step, go ahead and do so. Again, using distributive property to multiply these two polynomials. So you're actually saying a negative x times 6y cubed plus a negative x times the second term. What's the second term? Negative 5xy squared plus a negative x times the third one. And what's the third one? X squared y plus a negative x times the last term, negative 5x cubed. All right, so that's what I have. Now again, you could have skipped that step. So let's talk about the first product then. And remember, put the coefficient first, and let's write in alphabetical order. So if I do that, and in the first term, am I using the product rule at all? No, because in the first term, and I'm multiplying like bases. No, none of them are like bases. But remember, put them alphabetical order and put the coefficient first. So when knowing that, how would you write that first term?
Negative 6xy cubed.
Very good. Negative 6xy cubed. All right, over here, and remember, this coefficient right here that I'm pointing to, what's that understood to be?
1.
Negative 1. So what's a negative 1 times a negative 5? Right, so you're gonna write as plus 5, whatever the variables are. Okay, so let's write the x first. So what's gonna be that factor right here? 5 what? X squared, because x to the first times x to the first is x to the second. And then what about the y factor? Y squared. All right. Next one. What's going to be that coefficient right here? Yeah, so I'm going to write it as negative 1, but we tend to leave that 1 off. So, okay, but x cubed, right? And then what? Y. So you see it's just right as negative x cubed y. All right? And then finally, a negative x times a negative. So a negative times a negative is a positive. So I'm going to say a plus here. And then plus what? 5x to the 4th. Are any of these like terms? No. So there's your answer. That was 28. All right, number 30. You have 1/3 y squared times 9y squared minus 6y plus 1. So 1/3 y squared times that trinomial. All right, so again, if you need to write in that step, you're saying 1/3 y squared times the first term. What's the first term? 9y squared plus 1/3 y squared times that second term, which is a negative 6y, plus 1/3 y squared times that third term, which is just 1. All right. Now let's multiply that first product. What's 1/3 of 9? 1/3 times 9? 3. All right, so it's going to be 3 what though? Y to the 4th. All right. What's 1/3 of a negative 6? Negative 2. But it'll be minus 2 what? Y to the 3rd. All right, now here you're going to leave it as a fraction. So what's the third of 1? What's 1/3 times 1? 1/3. So you're going to say plus 1/3 what? Y squared. So there's your answer. Okay? All right, so that's all you do. So you have one like that on your test a week from Tuesday. So it's an easy thing. So let me go ahead and give you the worksheet that goes with that. Okay, so 12.6. Now, remember we just talked about the distributive property, correct? So if I have, just kind of like a quick review, if I have 2x squared times, let's say negative 2x squared, times 7xy minus 2x squared plus 7 minus 6y. Let's say I had that. And the direction will say multiply. All right, that's all I was going to say. So you have to know on your test that when you see this, how are you going to multiply what you see? Distributive property. Notice all I said was what you see. So this is what you see. You have to know, though, what you're seeing is this. You have a polynomial times a polynomial. This polynomial is a monomial. And so when you have a polynomial, more than one term right here, times a polynomial that's one term, what property are you going to use? Distributive property. Okay, so that you have to be able to think as you go through this. What do I have? And what you have determines how you're going to proceed. So what's a negative 2x squared times a positive 7xy? Good. What's a negative 2x squared times a negative 2x squared? A positive 4x what? Okay. What's a negative 2x squared times a positive 7? Negative 14x squared is what you said? Yes. All right. And then what's a negative 2x squared times a negative 6y? Positive 12x squared y. Very good. And are any of these like terms? No. All right. Okay, so remember we use the distributive property. All right, now here's the next idea. All right, now remember what we did, all those problems we just did, it was a monomial times a polynomial, right? A monomial times a polynomial. All right, so look at this that we're about to do. So again, let's multiply. All All right, suppose I had 2x plus 5 times 3x plus 2, let's say. All right. So the direction says to multiply. All right. Now, the one we just did, we were multiplying a polynomial times a polynomial. Am I doing the same thing here? Am I multiplying a polynomial times a polynomial? Yes. It just so happened that the one I just did, this was a monomial. These are two what? Binomials. All right. Now, you may remember this word, FOIL. Remember the word FOIL? F-Y-L? But before we get to FOIL, let's do this the way that they intended you to do it at the beginning, and then we'll go to the FOIL idea. If I cover this term up right here, all you see is a what? Yeah, but what is it? A monomial. So how would I multiply this polynomial by this monomial? Distributive property. Okay, so listen carefully. So what I have is this. I have 2x, this 2x times this binomial. So it's 2x times what? 3x plus 2. All right. Now if I cover that 2x, I also have that same idea, right? So I also have the idea of that positive 5 times what? 3x plus 2. So here's the idea. So I'm still using distributive property. I'm still using distributive property, but look at how it's being done. You're taking each term of that first polynomial. You're taking each term of the first polynomial and you're going to distribute into the second. You see 2x times what? 3x plus 2. A positive 5 times what? 3x plus 2. Now you're going to use the distributive property again. So what's 2x times 3x? 6x squared. What's 2x times a positive 2? All right. What's a positive 5 times 3x? Okay. What's a positive 5 times 2? 10. So that's what I have. So how many terms do you see right here? 4. Can I combine any of them? Yes. The 4x and the what? So putting this in descending order, what do I get?
6x squared.
Okay. What else?
19x squared.
Not 19.
19x.
19x
Plus 10.
plus 10. Okay, so there's your answer. All right, let's do another one with the two binomials. All right, so let's write this as number 1, and this would be number 2. Number 2. So this time, let's suppose we had 3x minus 4 times 5x plus 6, let's say. All right, so 3x minus 4 times 5x plus 6. Let's use distributive property. So notice I have, it says multiply, and makes you understand that you're multiplying two polynomials together. Except this time, you have a binomial times a what? A binomial. But I can still use the distributive property from what we did today. All I got to do is take each term that's in that first polynomial and multiply by the second polynomial. See what I'm doing? So what's that first term you see? So I got to multiply by the other polynomial. What's the other polynomial? 5x plus 6. Now what's the other term that's in the first? Negative 4. Negative 4. Negative 4 times what? 5x plus 6. And now distribute. Distribute. So what's 3x times 5x?
15x squared.
15x squared. What's 3x times 6?
18x.
What's a negative 4 times 5x? Good. What's a negative 4 times a positive 6? All right. How many terms do you see? Can I combine any of them? The middle two, right? So now remember, if you don't remember your sign numbers, use your calculator. What's a positive 18 and negative 20? Okay, so we get negative 2x. I get 15x squared minus 2x minus 24. Okay? All right, now, the way most students do this, though, when they see the two binomials, and this only applies if it's two binomials, is the FOIL method. So you remember the word FOIL? Who has never heard the word FOIL? First, outer, inner, less. Very good. Yeah. So you can multiply. You can multiply. Now this only works if it's two binomials. If it's a binomial times a trinomial, it doesn't work. You'd have to use the distributive property we just did. All right, but it only applies with two binomials. So you can multiply two binomials using FOIL. All right, now the one on the worksheet, so let me just kind of show you what the worksheet says so you understand what you need to be doing. So the worksheet that you're going to get says this, and it's very simple. It says multiply using the FOIL method. All right, so I need for you to show the four terms. You understand the four terms I'm talking about? Right here. So here's the FOIL method. I need to see those four terms, right? And then your answer. All right. Now, but that's the four terms I'm talking about. Now, we did this. We didn't use a FOIL method. What method did I use here? Distributive property. That's what I used. So you may say, well, I'm just going to use the distributive property. No, I need for you to use the FOIL method, which involves the distributive property, but that's not what this is. You actually distribute. You took each term of the first polynomial multiplied by the second. That's the distributive. So I need to see the FOIL method, though, because that's going to be important next semester, because next semester, most of what you're going to do is factoring. And one of the things you need to know how to factor when you factor trinomial, you're using the reverse FOIL. So you got to know what foiling is in order to be able to factor next semester. Okay, so here's how we're going to do this. All right, so you can multiply two binomials using FOIL, and the F here stands for first, meaning the first terms. I'm going to put this first term of each binomial. All right, first term of each binomial. The O stands for outer, which would be the outer term of each binomial. The I stands for inner, so the inner terms. And the L stands for last, so first, inner, outer, last. And that will be the last term, the last terms. The last term of each binomial, Okay, it's very simple. It's a very simple process. All right, so let's do an example. So multiply using FOIL. Now notice it says multiply using FOIL. FOIL. Multiply using FOIL. So your test, the directions will say that. So I need for you to be able to, on your test in a week from Tuesday, be able to multiply two binomials together using FOIL. It will say FOIL, so follow the directions. So if you use what we just did here, you're not going to get hardly anything because you didn't use FOIL. You use a distributive property. Okay? All right. So let's look at a simple example first. So let's do this one. Let's say we have 6x plus 5 times 7x plus 2. So 6x plus 5 times 7x plus 2. Can I use FOIL here?
Yes.
Why can't I use FOIL?
Because
I'm multiplying two binomials. All right, so do the order FOIL. So first, do F first, then O, then I, then L. All right, so the first says I take the first term of each binomial and I multiply them together. So what's that first term of the first binomial?
6x.
What's the first term of the second binomial?
7x.
What do I do to 6x and 7x? multiply them. All right, so you're going to say this times this. So a lot of students, when they do the FOIL, you may remember the little arcs, the little curves that you make. So the first times first. So what is 6x times 7x? 42x squared. Okay? Now let's go to the outer. The outer, I didn't mean here the outer term of each binomial. I'm just going to take each binomial out. Take those words out. So just say outer terms. Now, here's something about outer terms. If you look at this expression right here, what term's on the outside that you see? No, the outside. The xx, 6x and what? 2. So that's the outside. That's the terms you see on the outside. So it's kind of let's say these are 4 people in a row. So which people are on the outside of that row? The 6x and the what? The 2. Okay? So you're going to say 6x times 2. So that's your outer. Okay? So that's your outer. So that's the O. That's your outer. What's 6x times 2? 12x. All right, so just make sure you take out the word of each binomial because that's not what I meant. Now, the people on the inside, the inner people, I'm calling them people, the inner terms, 5 and what? 7x. Okay, so that's your inner. So what's a positive 5 times a positive 7x? 35x. And then now I'm saying the last term of each binomial. What's the last term of that first binomial? What's the last term of the second binomial? 2. What do I do to those 2 terms? Multiply them. So that's your last. So what's a positive 5 times a positive 2? And notice how many terms do you see? 4. Just like when we did the distributive property a while ago, there were 4 terms. Can I combine any of them? Yes. So normally not always, but normally what's going to happen is that you'll be able to combine the outer and the what? The inner. So what's 12x and 35x? All right, so what's the answer?
42x squared
Plus 10. So that's your answer. So that's the FOIL method. All right. Let's look at this one. All right, so let's say we had this. So this is going to be number 6. Let's do this. This is number 6 on page 933. And the title, remember I said I was going to take the title off for the moment? So the title here is just going to, the title is Special Products. What we're doing here, though, the special product is the FOIL method. So the FOIL. FOIL. All right, number 6. Here's number 6. You have 3y minus 5 times 2y plus 7. So 3y minus 5 times 2y plus 7. Now, when you multiply polynomials, you can use the distributive property to begin with, but I don't want you using that idea. I want you to use the FOIL method. Now, the FOIL method is a form of the distributive property, but it's not what we just did. So don't do this right here where you took each term multiplied by the other polynomial. Don't do it that way. All right, use the FOIL method. First, outer, inner, last. All right, so let's talk about the first. So remember, F stands for the first term of each binomial. What's the first term here?
3y.
What's the first term here? 2y. So put a little curve here, a little arc joining the 2. So it's 3y, and you're multiplying because what's this operation right here? Multiplication. So that's why you're multiplying. So what's 3y times 2y? 6y squared. So that's my first. All right, now the outer. So the outer means the terms that are on the outside of that row. So what are the terms on the outside of the row? 3y and a 7. So that's your outer. So what's 3y times a positive 7?
Positive 20.
Right, so that's your outer right here. So that's your outer. Okay? The inner, the terms on the inside. The terms on the inside. What terms on the inside? Negative 5 is 1, and what's the other? 2y. So what's a negative 5 times 2y?
Negative 10.
negative 10y. All right, and then the last is the last term of each binomial. What's the last term of that first binomial?
-5.
What's the last term of the second binomial? Positive 7. So this was your inner, and this is your last. So what's the negative 5 times a positive 7? All right. So that's your 4 terms, and now the directions. Let's go back to that worksheet real quick. So it says multiply using FOIL. All right. So I need to see, here's what I need for you to show me, okay? I need to see those little arcs. So first, outer, inner, last. Okay? Show that. So that indicates to me you use FOIL. Then it says show the 4 terms. So these are the 4 terms you're going to show, right? Then it says put the simplified answer in the blank. So what do I mean by the simplified answer? When you do what to those terms? Combine them. Okay, so what's your answer? Plus 11y, good. Minus 35. So that's your answer. Okay? All right, now, let's look at this. So that's number 6. Okay, now what if you had this? Right, this is going to be number 22. Okay, you have 7x minus 3 squared. 7x minus 3 squared. And again, I want you to use the FOIL method. You may say, well, it doesn't look like the others, but you can make it look like the others. Because what does 7x minus 3 squared? What does that binomial squared mean? 7x minus 3 times itself, right? Times itself. So that's 7x minus 3 times 7x minus 3. So we read it like that, and now you can use the FOIL method. So make sure you draw those little arcs, though. So to the f means the first term of each binomial. So I'm going to join 7x with what? 7x. What's 7x from 7x? Okay, good. Then the outer, so the terms that are on the outside of that expression, those 2 binomials. So what terms on the outside, which are they? 7x and a negative 3. Okay, good. So that's your outer. So what's 7x times a negative 3? All right. Then the inside terms. What terms on the inside? Yep, negative 3 and 7x. So what do you get? Negative 21x. And now your last terms, the last terms of each binomial. What are the last terms of each binomial? Well, negative 3 and a negative 3. Okay? Which is what? Positive 9? Now notice, you see I had that binomial squared? I want you to notice something about those 4 terms. Remember I had that binomial being squared, right? Whenever it's a binomial squared, the outer and the inner terms are exactly the same. See that? They're exactly the same. All right, so when I combine them, what's going to be my simplified answer? Minus 42x plus 9? Okay, plus 9. So notice the only reason why this time that the out and the inner were exactly the same term, were identical, is because I was squaring a binomial. All right, let's look at, all right, let's do this, let's see, let's do this example. All right, let's write this example. So this is going to be example. Let's suppose I had 2x plus 5y times 3x minus 2y. So 2x plus 5y times 3x minus 2y. FOIL method. So you can draw those little arcs. Draw those arcs. So I'm going to do the f first. So first term of each binomial. So I'm going to combine which two terms? 2x and 3x. And when I say combine, I mean I'm going to connect them with this arc. But I actually am doing what to those two terms? What operation? Multiplying. When I say operation, I mean multiply, add, subtract, or divide. So what's 2x times 3x? 6x squared, right? Right? Okay. Now the outer. So that's the terms on the outside that you see. What terms on the outside? 2x and negative 2i. So what's 2x times a negative 2i?
Negative 4xy.
Negative 4xy. Correct?
Yes.
Okay. Now the inner, the terms on the inside. What are the terms on the inside?
5y and 3x.
5y and 3x. When I multiply 5y and 3x, and let's put it in alphabetical order, what do you get?
15xy.
15xy. And now the last term of each binomial. What's a positive 5y times a what? Negative 2y. So what's a positive 5y times a negative 2y?
10y squared.
What kind of 10y squared?
Negative.
Negative. All right, so that's my four terms. Can I combine anything? Yes. The xy's, right? So what's a negative 4xy and a positive 15xy?
11xy.
Okay, good. So I get 6x squared plus 11xy
Yes.
and then minus 10y squared.
Yes.
Okay, that's your answer. All right. Okay, number 34. Suppose you had this. All right, 34. You have 4s, that's an s, minus 2y squared. 4s minus 2y squared. Now, before we do this, notice I'm squaring a binomial, so the outer and the inner terms better be what? The same. They better be the same. So if they're not, you did something wrong. All right, but first of all, you're going to rewrite this. How are you going to rewrite this?
4x
Minus
minus
2y
2y
times 4x minus 1.
Very good. All right, and then do the FOIL. So when I do f times f, the first term of each binomial, that's 4s times what? 4s. What's 4s times 4s?
16x squared.
16x squared. The outer terms, the terms on the outside, that's 4s and a what?
Negative 2y.
Negative 2y. Let's put it in alphabetical order. So that's going to be what? Negative 8sy. Okay. The inner, the terms on the inside, that's this. What do I get? Negative 8sy. Now, the outer and inner terms the same? Yes. And then next, the last term of each binomial. So a negative 2y times a what?
Negative 2y.
All right, what's the negative times the negative?
Positive
All right.
4y squared.
4y squared. All right, and so therefore your answer then will be what?
16x
16s squared
minus 16sy
16sy
plus 4y squared.
plus 4y squared. All right, so that's 34. All right, let's look at this one. So this is going to be number number 12. So number 12. All right, 12, you have y squared plus 3 times 5y plus 6. There's number 12. Okay, so fall method. First times first. So let's do the first term of each binomial. What are the first term of each binomial? Y squared and a 5y. So what do you get? 5y to the third. Okay, now the outer. What are the outside terms? Y squared and what else? 6. What do you get when you multiply them? 6y squared. Now the inside. What terms are on the inside? 3 and 5y. What do you get when you multiply them? 15y. And then the last term of each binomial, which is going to be 3 and what? 6, which is 18. So there are your 4 terms. And therefore in the blank, it's right, because you cannot combine anything, right? So you're just going to rewrite. You're going to say the answer will be 5y cubed plus 6y squared plus 15y plus 18. Okay? All right. Okay, number 14. All right, 14, you have x minus 2/5 times x plus 1/5. So x minus 2/5 times x plus 1/5. Right. You have fractions, no big deal. You've been dealing with fractions since day one. Use the FOIL method. So x times what? Is x squared. The outside, x times what? 1/5, which is 1/5 x, right? Okay. The inside, negative 2/5 times what? Which is a negative 2/5 x. All right. And then finally, what's a negative 2/5? This is what you have. You have a negative 2/5 times 1/5. Just write it down if you need to. Now, negative 1/5. No, no. No, no, no. Negative 2 over 25. You're multiplying fractions, right? So you multiply numerators together. What's negative 2 times 1? Negative 2. And what's 5 times 5? 25. All right, guys. So it's negative 2/25. So remember, you're multiplying fractions. All right. Okay, now can I combine anything? Yes. The middle. So now look, the coefficient is 1/5, and you're adding a what? Negative 2/5. Now remember, I'm adding two fractions with the same denominator. So I add the numerators together. What's up 1 and a negative 2? Negative 1. So what's 1/5 and a negative 2/5? Negative 1/5. So therefore your answer in the blank is going to be what? X squared minus 1/5 x minus 2/25. Okay? All right. So remember, here you're multiplying fractions, here you're adding fractions. So when you multiply fractions, you multiply numerators together, multiply the denominators together. When you're adding fractions or subtracting fractions, you have to first of all make sure your denominators are the same, and they are here. Then all you do is add their numerators together. So 1 and a negative 2 is a negative 1. So you get negative 1/5. All right, let's do this one. Okay, what if you had this? 2x minus 3/4 squared. 2x minus 3/4 squared. So let's do another one with a fraction in it. So what does that mean, though? How are you going to rewrite it? Yeah, 2x minus 3/4 times 2x minus 3/4. All right. Okay, let's do the first. What's 2x times 2x? 4x squared. Okay, now the outside. So look what we have. We have 2x. So here you may need to write it. May need to write this because you are dealing with a fraction. So 2x times what? A negative 3/4, right? Okay, so 2x times a negative 3/4. Now, here's the way you may want to do this so you don't mess this thing up. I can write 2x as 2x divided by 1. Okay? So you see I'm multiplying fractions, right? Now, here's what you need to do. What's 2x times a negative 3? Negative 6x. What's 1 times 4? and then just reduce negative 6/4. What's negative 6/4 reduced? So that's negative 3x divided by what? 2. So I get minus 3/2 x. You all agree?
Yeah.
Okay, so notice what you did. You multiply the 2. You said 2x times negative 3/4. You wrote 2x as 2x divided by 1. Then you multiply the numerators together, multiply the denominators together, and you reduced. 6 and 4, they have 2 in common. They're both divisible by 2. Now the inner, you're going to do the same thing. But here's the thing, though, is what you got to remember. The outer and the inner are going to be what? The same. So if you did this one correctly, then the inside term also has to be what? Negative 3/2 x. Okay, because you're squaring a binomial. We talked about that a while ago. When you square a binomial, the outer and the inner are going to be the same. And it is because, look, you're saying 2x times a negative 3/4, that's your outer. The inner is the same thing. 2x times a what? Negative 3/4. So they have to be the same. All right, now let's do the last. What's a negative 3/4 times a negative 3/4? No. 9 divided by 16. Now what you are doing is adding the inner and the outer. That's what you were doing. But that's not what I asked. I said what's a negative 3/4 times a negative 3/4? That's 9 divided by 16. So that's plus 9/16. Okay? Now let's combine the like terms. All right, now you may need to write this out again. So look, I'm going to do this here. A negative 3/2 and a negative 3/2 is what I have, right? Y'all agree? All right. I'm adding two fractions with the same denominator. If the denominators were different, you'd have to find the LCD, but they're the same here. So you add their numerators together. What's a negative 3 and a negative 3? Negative 6. So that's negative 6 divided by what? 2. What's negative 6 divided by 2? Negative 3. So now, what's a negative 3/2 x and a negative 3/2 x then? Negative 3x. So what's the answer? Yeah, minus 3x though. Plus 9 divided by 16. Okay? All right, let's do one more. The one in your test is not going to have a fraction on it. I did fraction because you may see, or you will see actually, one in my math lab. So I did put one on the worksheet, but on your test, I'm not going to put one with a fraction on it. So you should be okay. And you're not going to see that in the final either, the fraction. All right, so let's do one more. All right, this is an example. Let's suppose you had 6x to the 5th, 6x to the 5th, plus 7 squared. 6x to the 5th plus 7 squared. All right, so what are you going to do? Multiply by itself. So you're saying 6x to the 5th plus 7 times 6x to the 5th plus 7. And then use the FOIL method. So what's 6x to the 5th times 6x to the 5th? 36x to the 10th power. Because when you multiply bases, you add exponents. 5 plus 5 is 10. What's the outer? 6x to the 5th times 7, which is what? 42x to the 5th. Now remember, I'm squaring a binomial, right? So if I'm squaring a binomial, if the outer is 42x to the 5th, then the inner also has to be what? 42x to the 5th. Y'all agree? And it is. 7 times 6x to the 5th is 42x to the 5th. So you still get the same thing. And then the last, what's a 7 times a 7? And so therefore, what's your answer? To the 10th plus 84 x to the 5th plus 49. Okay? And that was it. That's all I need you to know for the test. Now, we're still not done with this section. So I can't open up my math lab, but at least you know the fall method for your test. And there's only one problem with it. You're not going to have a fraction, so just be able to do the other stuff. All right, now when I give you the worksheet looks like this. Just going to show you. So you multiply two binomials, two binomials, two binomials, two binomials. Again, how are you going to rewrite this? It's 2x minus 3 times itself. All right, and then we did one like that. It turns out that none of those are like terms, so you just write that answer down. And then these are squaring. Here's the one with a fraction in it. All right, and then we just did one like that. Okay. All right. So that was the fall method from section 12.6, part A. Graph. So let's graph. Again, this is section review 10.2. All right, so let's graph y equals negative 2/3 x plus 4. Negative 2/3 x plus 4. So you have a fraction here. You have a fraction. And the good thing is that y is by itself, so it makes it a little bit easier to deal with. Y is by itself. So you use a t-table. And remember, one of the numbers you want to use is 0. 0 makes things a lot easier. That's a good number to use, is 0. So if x is 0, I get y equals negative 2/3 times 0 plus 4. And what's negative 2/3 times 0? And 0 plus 4 is 4. Okay, so I get the ordered pair. Remember the word ordered pair. I get the ordered pair 0, 4. All right, now, the other numbers we use for x, remember, pick one that's positive and one that's negative. But let's be strategic this time because I have a fraction involved. So let's pick numbers of x that are divisible by this denominator. So what numbers, what integers are divisible by 3? 3, negative 3, 6, negative 6. So all you do is take multiples of 3, right? 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and then the negative components. So let's use 3. So if x is 3. So I get y equals negative 2/3 times 3 plus 4. Y'all agree? What is this right here that I'm circling? What's negative 2/3 times 3? Negative 2. If you don't see it, make sure you write it like this then. Negative 2 times 3 is what? Negative 6. 3 times 1 is 3. Reduced is negative 2. And what's negative 2 plus 4? 2. So I get the ordered pair 3, 2. Now let's do the other, let's do a negative value for x. So let's choose negative 3 this time. So you see, notice that by being strategic, I don't have any fractions involved at all within my coordinates. And that's why I wanted you to use multiples of the denominator. So negative 3, you're going to say y equals negative 2/3 times negative 3 plus 4. Okay? What is a negative 2/3 times a negative 3? Not positive 6. No, you're multiplying the numerators. The numerator is a positive 6, but what's negative 2/3 times a negative 3, though? Huh? Come on, guys. You have a negative 2/3 times a negative 3 over 1, correct? Okay. What's negative 2 times negative 3? 6. What's 3 times 1? So what do you get? 2. You get 2. You get 2. And what's 2 plus 4? 6. All right. So then all you do now is just plot those 3 points. Plot those 3 points and draw your graph. All right. 0, 4 is located where? Which axis? The y. The y-axis, right? So when we start the origin, since x is 0, you stay there. Y is a positive 4, you move up 4. 3 2's in what quadrant? The first. So you plot the point 3 2. Oh, the 3 2. 3 2 is here. So this is incorrect right here. That's 3 2 right here. And if it says label, it means you actually write in the ordered pairs. And then negative 3 6 is in what quadrant? The second, negative 3 6. All right, so that's negative 3 6. And then you just draw your line going to those points, just like this, and you make sure you have arrows. And so there's your line. Okay, so that was y equals negative 2/3 x plus 4. Any questions? So in your study guide on section I lost that page. Okay, your study guide, the one that's on 10.2. In the back page. There's only one problem. All right, so one problem from 10.2. So that's a graph thing. We just talked about these two right here. All right. In 10.3, what was 10.3? Oh, okay. All right. So 10.3 is this. Okay. So we're not going to be able to do 10.3 today because we're running out of time. But 10.3 is on the x and y intercepts. So that's not going to be in your test. It'll be in your final, though. They usually have something about x and y intercepts in your final. So just cross this out and put final. That's what we needed for the final. So we're going to do that next class period. All right, so cross that one out and write the word final here. What I need for you to do, though, is start going through all of these. Going through all of these. All right. You have now the worksheet you turned in last class period, I haven't graded it, but you have the keys. You have the keys that you picked up to help you go through this. And then if you lost your worksheet, where do you find it? On Canvas. You go to Canvas. Okay? All right, so let's see what you're turning in.